Solving systems by substitution is a really nice strategy because it's one that you've been practicing for ages. All we're doing is plugging the information from one equation into the other equation. So if we start with the system that looks something like this, we have y equals 2 as one of our equations, and a negative 5x plus 4y equals negative 22 as the other equation. What we're going to do is we're going to take the worth of one variable and plug it in for that variable in a different equation. So in this case, you can see we have y equals 2 already set up and ready to go. So I'm going to take y equals 2 and plug 2 in for y in the other equation. So I would have a negative 5x plus 4y equals negative 22. And the value that I'm using for y is 2. That gives me negative 5x plus 8 equals negative 22. Subtract 8 from both sides. Negative 5x equals negative 30. Divide both sides by a negative 5. And x equals a positive 6. So I can take this information, x equals a positive 6, and combine it with the information that we were given that y equals 2, and I could write the exact location of the solution for this system. And that would be when x is 6, y is 2. Now, it's kind of nice to know that the number of variables you have tells you how many equations you will need to find the solution to a system. So we're working problems right now that have an x and a y variable, which means we need 2 equations to solve the system. So let's look at another example of solving a system using substitution. But let's pick one that's maybe not quite as straightforward. Let's say that in this system we have 2 equations. One is y equals negative 8 and the other y equals negative 8x minus 8. Now, you can see in the pink equation that we have y equals negative 8, so we could plug in negative 8 for the y value in the other statement. So if I were to take my y equals negative 8x minus 8 and replace y with the value of y, then I would have negative 8 equals negative 8x minus 8. I'll add 8 to both sides. Happens to cancel out on both sides, leaving me 0 on the left, negative 8x on the right. We'll just keep going. Divide by the coefficient, and we have 0 equals x. Remember, we already know that y equals negative 8, so we have our solution. Put it right down here. We have our solution when x is 0, y is negative 8. All right, let's do one more. Oops. See if we can shrink these down somewhat together here. All right. Let's take a look at one more system. This time, though, we're going to work with a system that doesn't really have anything set up ready for us to work with. Okay, so I think I'm going to try and separate this here a little bit. Let's go to a new slide. All right, let's start with our system. The system is going to be a 6x plus 3y equals negative 9 and 5x plus y equals negative 9. Now notice neither of these equations in this system are ready to substitute. We don't have a y equals or an x equals anything. So I'm going to look at all 4 variable terms and see which one is going to be the easiest to isolate. Since these 3 all have coefficients, I'm going to isolate this y because it's just faster, right? Fewer steps in order to isolate that y. So let's go ahead and look at that. We're just going to put it right over here. We have 5x plus y equals negative 9. And if I subtract 5x from both sides, I have y equals negative 5x minus 9. And now I'm ready to take what y equals and plug it in for y in the other equation. So let's take a look at this white equation over here. We have 6x plus 3y equals negative 9. I'm going to replace y with what y is worth. So 6x plus 3y, and then we'll plug in what y is worth over here, which is a negative 5x minus 9. So we have 6x, and we need to distribute the 3. 3 times a negative 5x is a negative 15x. 3 times a negative 9 is a negative 27. And we'll bring down the minus 9. Oh, I've forgotten my equal sign here. Not change the equation on you. All right. Let's combine like terms. We have 6x minus 15x gives us a negative 9x minus 27 equals negative 9. So now we'll add 27 to both sides. We'll have a negative 9x equals 18. Divide both sides by a negative 9, and x equals a negative 2. We can take this x value and plug it back in to either one of the equations in the original system. So let's go ahead and plug our x value into that pink equation. So let me write it down. We have 5x plus y equals negative 9. And if you'll remember, the x value that we found is negative 2. So we're going to plug that x value in for x. So we have 5x plus y equals negative 9, and the x value we found was negative 2. 5 times negative 2 is a negative 10, plus y equals negative 9. We'll add 10 to both sides. So y equals negative 9 plus 10, which is 1. We're going to take those two pieces of information, put them together for our solution. When x is a negative 2, y is 1. So there is the solution to our system. using substitution.